Hello, everyone. I want to welcome you all to my talk today. And this talk is titled Optimize Continuous Delivery Pipelines. And in this talk, I'm going to be speaking to you all about how you can optimize your continuous delivery processes and then eventually reflect those in your pipelines. Before we get started, I just want to cover a quick agenda of the things I'm going to be speaking about today. I'm going to cover a really quick intro about myself, tell you who I am and what I'm about, and then I'm going to jump into discussing, SDLC, which is software development life cycles, and how they relate to continuous delivery. And then I'm going to jump into speaking about continuous delivery at scale, right, and delivering your software at scale. And finally, I'm going to talk about optimizing pipelines as well as a recap of all the things that I'm going to cover today. So my name is Rivera. I'm a developer advocate for Circle CI. And essentially what I do as a developer advocate is engage the developer community, the developer industry, or the tech industry in general, and understand how folks are using technology, understand some of the problems that they're having, and some of the successes that they're having. But what I do is bring all those learnings back to my team so that they can incorporate very valuable features for our developers and our users so that they can deliver their software as quickly as possible. If anybody wants to reach out to me, I'm easily accessible on Twitter. @punkdata is my Twitter handle. So yeah, if you just want to chat about this talk or chat about technology or anything really in particular, just reach out to me. I'm open for all conversations. So let's talk about software development life cycles and continuous delivery. So software development life cycles are basically processes used by the software industry to design, develop, and test high-quality software. The SDLC aims to produce high-quality software that reaches completion within times and cost estimates, right? So if you have deadlines, the software development lifecycle will help you keep that on track as well as staying on budget. The SDLC is also known as the software development process, right? So there are many SDLC methodologies that organizations use to deliver software. Waterfall and Agile are the most commonly used. Waterfall is a bit older and follows a sequenced cascading model where tasks are assigned in bulk and usually depend on previous tasks being completed before work can begin on the next tasks. In contrast, the Agile methodology breaks tasks down into smaller, more focused portions, enabling developers to complete them much faster. And Agile tasks usually don't have strict dependencies, right? So this also, right, having the minimal dependencies enables developers to complete multiple tasks concurrently, which dramatically drive down or actually increase productivity. With this increase in productivity, developers identified efficiency and patterns within the SDLC that can further optimize and increase productivity, resulting in releasing software faster. Continuous delivery was born out of these findings and is an essential practice in modern-day software development. Continuous delivery is the practice of producing software in short cycles and essentially implementing automation, which helps the users and the developers basically build their software faster and more reliably and more consistently. Continuous delivery is the overall concept in developing software within the software development lifecycle. And within continuous delivery, there are more specific concepts that guide developers producing software efficiently. Continuous integration and continuous deployment, also known as CI/CD, are closely related, but they are distinct concepts that support continuous delivery. Let's talk about continuous integration. It's essentially the practice of merging all developers' working copies into a shared code repository. And here are some of the benefits of continuous integration. So, we're writing smaller portions of code or functionality. We're committing those code changes often and to a shared repository. That the code is tested on every commit instead of manually being tested. And then my favorite benefit of this the continuous integration is fast feedback loops. So essentially, the developer is actually being informed of what's going on with their code that they just wrote. And they're able to understand if there's any problems with that code that they just wrote. So if they have any failures in their build processes, right, they're alerted to those failures quickly, and they're able to very rapidly fix those issues or work on them and fix them, and then submit those changes. So again, it's a continuous loop of checks, right? And the fast feedback loop is that notification that, hey, something's wrong. With continuous deployment, right, it's essentially the practice of automatically deploying new software releases to a target environment. And on a conceptual level, here's some of the benefits, right, or principles of continuous deployment. You create release artifacts for your deployment processes. You deploy those artifacts to whatever target resources or the resources you're targeting. You can validate your applications and services are functioning after deployment, right? And then you're monitoring the state of that deployment to ensure that if there's any failures, you may also have some auto recovery type functionality built into your processes, right? Your deployment processes. So I described SDLCs, continuous delivery, and continuous integration, continuous delivery, CI/CD, as concepts and practices that teams adopt and implement to build software efficiently. These practices are very helpful, but they are almost always effective when paired with automation. Automation brings life to these concepts and facilitates automatic execution of processes while eliminating the need for manual intervention whenever possible. Automation brings speed, reliability, and consistency to software development. Combining automation and the CI/CD concepts are often referred to as CI/CD pipelines. Pipelines define an aggregate of segmented software development tasks collectively producing software releases using automation. These segments are generally known as jobs and represent the commands executed by the automation. CI/CD platforms like Circle CI bring the automation that defines, orchestrates, and executes jobs within these pipelines. So here's a quick visual of what a CI/CD pipeline looks like within the Circle CI dashboard. As you can see, there's a bunch of jobs that are running concurrently. In some cases, we have to add dependencies, but at the end of the day, everything here is a direct reflection of some CI/CD or at least continuous delivery and SDLC combination of their processes, right? So the continuous delivery concept reflects your SDLC processes, and it automates those processes to ensure that everything's running consistently and efficiently. So let's talk about continuous delivery at scale. All of the development concepts I described are designed to help in releasing quality software efficiently. They provide very general guidance, enabling teams to adopt and implement elements that fit their situations. Aligning and automating all of these processes is a huge undertaking and requires lots of iterative experimentation to produce valuable CI/CD pipelines. As you can see, continuous delivery and CI/CD concepts mainly pertain to the software development, testing, and deployment elements of the SDLC. So over time, it's inevitable that your projects, repositories, and code will grow in complexity and in volume, which will present many challenges in maintaining efficiencies and, more importantly, velocity. Establishing and maintaining and scaling mechanisms that provide solid support for pipelines is very difficult to achieve without constant surveillance and interactive reviews. A common issue produced from lack of pipeline management is misaligned segments within your software development lifecycle. Misalignment of software development and CI/CD processes can produce a substantial reduction in quality and productivity, resulting in buggy releases and slower release cycles. A common issue produced from lack of pipeline management is misaligned segments. Misalignment of software development and CI/CD processes can produce a substantial reduction in quality and productivity, resulting in buggy releases and, again, slower release cycles. So any disparity can cause damaging results, such as processes that are confusing among teams, diminish quality amongst the product that you're producing, wasted cycles, which are very expensive, and then slower release cycles, obviously. You will not be able to maintain efficient software release cycles if these processes are not properly aligned. CI/CD pipelines are automated reflections of your software development and continuous delivery processes and must not be neglected. CI/CD tooling and platforms are critical for managing pipelines at scale. CI/CD platforms come in various flavors. Some platforms are strictly CI/CD focused and provide solid, performant, robust tooling that enable teams to focus on developing software, while other solutions come in the form of bolted-on CI/CD features within bulky all-in-one solutions where CI/CD is not the primary focus. Adopting and implementing capable CI/CD solutions is paramount in executing continuous delivery at scale. Circle CI is an example of a platform, CI/CD platform, that is solely focused on CI/CD and does not, and it's not a bolt-on to a bigger solution, right? Like an all-in-one solution. So teams must understand that reliance on CI/CD tooling and execution is essential and will increase dramatically, further cementing your CI/CD platforms as mission critical and will cripple productivity if not properly managed or maintained. Now I want to talk about how teams can optimize pipelines, some of the concepts and strategies that I have kind of in my head about how teams can optimize pipelines. So human capital, such as developers, are very expensive. And if software development and CI/CD processes are not performant or unavailable, the cost of wasted developer cycles is devastating. We have an estimate of developers' time per minute, and we roughly calculated that to be about $1.45 US dollars per minute for every developer, or for every developer minute. So, you can imagine if you're sitting around waiting for systems or your CI/CD pipelines for quite some time, it can get quite expensive. So optimizing pipelines in general is not a menial task, and it is a continuously moving target, but it can be accomplished keeping teams and release cycles humming efficiently. Next, I'll identify human and process-related components, then follow that up with technical strategies and suggestions for pipeline optimization. So aligning CI/CD segments with SDLC, let's start there. As I mentioned earlier, a common issue produced from lack of pipeline management is misaligned segments. Misalignment of software development and CI/CD process elements can produce a substantial reduction in quality and productivity, right? I already mentioned that. So disparity in development and CI/CD processes are huge performance killers. CI/CD pipelines are automated reflections of your software development and continuous delivery processes. So ensuring CI/CD workloads mirror the pertinent elements of your software development processes is critical in maintaining effective software release cycles, especially in high-performing teams. One method worth exploring is establishing a role that is effectively a CI/CD czar, or continuous delivery czar. I wrote a few blog posts on this topic, and in it I discussed the characteristics and duties of this role, which I believe will be crucial in optimizing pipelines. So here are some of the characteristics for this role that I'm discussing here. So again, right, these are not like unusual characteristics. Some of them include keen analytical skills, an ability to decompose complex problems, and then proficiency in automating processes. And the duty sides, these are things that the czar I envision them having to do, is developing CI/CD principles for your team, right? These are the conceptual kind of rules of engagement for your CI/CD practices, and then review and modify those principles iteratively. So making sure that the processes and principles that is developed by the czar and the team are actually adding value and not, hurting the team. Because, just because you come up with something today doesn't mean 3 months from now or 6 months from now, they're going to be valid and efficient, right, for your team. So you constantly have to, check and balance all of that out. And then the duties will also kind of, what I see happening is maintaining the CI/CD tools and platforms, right, if applicable. And then develop and maintain pipeline configurations, which is essentially the directives and the way you define and execute your CI/CD pipelines. So again, right, you're automating processes, and it does need someone's attention or a team's attention, right, to help the developer community or your developer teams, just worry about the code and then also engage in that whole continuous delivery process. So the previous suggestions I shared prevent inefficiencies related to the management of the practices and principles that govern software development and continuous delivery processes. Now I'll share some technical optimizations that address common areas where teams can focus on and maintain or enhance pipeline performance. So proficiency in the languages, frameworks, and resources in your tech stacks is critical. Knowing the capabilities, benefits, and limitations of these technologies that teams leverage improves overall quality of code and assists in understanding and resolving current or future performance impacting bottlenecks. For example, running tests suites concurrently by exercising a language's native concurrency capabilities in code usually provides huge performance gains. Run all jobs and workloads simultaneously wherever possible. Parallel job execution is not possible in all cases, especially in situations where jobs require successful completion. Running build jobs in parallel will dramatically decrease build job duration resulting in shorter pipeline runs. Pipelines are composed of individual jobs that define execution commands. These jobs may or may not have dependencies that are essentially blockers. I suggest eliminating these dependencies from the build jobs, if at all possible. Most tooling has caching mechanisms, and they should be used wherever appropriate. But I will warn that you must understand how the caching that you implement actually works, right? Because there is the possibility that the caching mechanisms that you implement or employ are not being used appropriately, which can then cause nasty side effects like inefficiencies and unoptimized performance within your CI/CD jobs and builds. So the way that you can prevent some of that is just, again, understand how caching works within that platform, and then only update the things that have been changed, right, to avoid downloading all the things and avoid updating the whole cache, the entire cache. All you want to do is upload or update the dependencies that have changed within your application or your stack. So pipelines are executed on compute nodes, which vary in capacity and resources. You want to ensure that compute nodes are appropriately sized for the workloads they're expected to process. So you want to make sure that it has proper CPU, that the node also has enough memory, RAM, right, to execute, storage space, maybe network bandwidth, right? These are just small things that folks don't really understand, or maybe they start off with less capable or capacity, right, in their underlying compute nodes when they're executing their builds, and then they come to realize that the stack has kind of outgrown those initial capacities on the compute nodes. So you have to kind of upgrade. So you gotta grow your execution nodes or your compute nodes along with your stack, right? So if you're using 4 gigs today and it's totally fine on a medium-sized compute node, and then your stack grows and it's using more memory, right? You definitely want to upgrade or at least increase the compute node resources so that those jobs execute properly and efficiently. Compute nodes, right, with larger capacities do cost more to operate, but the higher cost can be deceiving, especially when when it comes to build durations, right? you kind of get sticker shock sometimes because you're worried about, oh, it's going to cost me more money. But at the end of the day, by executing things on properly sized compute nodes, you actually make things run faster, and you actually shorten the time that is in the time that the job is using those resources. So essentially, this has happened to me real world. I've actually spent less money using, on a build per build, using more capable or more capacity type compute nodes rather than the defaults, which I was using that had less. So sometimes that sticker shock is deceiving, because again, right, you're giving it more horsepower, so the job should be getting done much more faster. One of the other kind of elements for optimizing pipelines is execute specific tests at appropriate segments of the software development process. So don't run end-to-end tests on every build for every scenario, right? Or every commit. You should ensure that your tests are being executed for appropriate points of your CI/CD pipeline. So if you're in development, don't execute all your end-to-end tests, right? You can do that at a later stage in your pipeline. Maybe you're going to do a promotion to staging or Q&A, right? That's more appropriate, a more appropriate place in your pipeline to execute the more complex, more robust testing that actually increases or should increase your build time, right? So yeah, just push those off so that the developers can just test the essentials and get back to work. So let's talk about conditional job execution. So this is where you should be orchestrating your jobs and ensure that they're executing using conditional logic. So you want to make sure that the CI/CD platforms that you use have some form of logic capabilities within the pipeline. This will help align the segments between the development and continuous delivery process that I was talking about earlier, and then execute jobs when certain conditions exist. So the last thing I'll leave you with for optimizations is set aggressive build durations for every build job execution to ensure that your jobs are completed in the shortest times possible. Setting these goals will drive awareness of threshold creep, where build durations become longer over time and slowly extend the duration of your workloads and when they run. So I know I went through that really quickly, but I definitely want to recap all the things that are, I want you to kind of take away from this presentation. So let's jump into a quick recap. So first, right, we want to align our CI/CD segments with our software development lifecycles. I would highly recommend that you establish a continuous delivery engineer role or a CI/CD engineer role within your organizations to kind of help move things along, ensure that the tooling is working properly, right? And essentially just taking ownership of your entire continuous delivery practice, right, within your organization and your teams. Have deep knowledge of the technologies you're using, such as languages, frameworks, and tooling. That will definitely help with the automation portions and keeping things ship-shape, right, and running smoothly. And then execute your workloads concurrently wherever possible. Again, we all have everything will have not everything, but some things will have dependencies. But if they don't need to be executed in sequence like that, then eliminate those dependencies and just execute things in parallel so that it just works, or it just moves a lot faster for your teams and your processes. So here's some more of the optimization of pipelines. Avoid, again, build job dependencies. These are some of the technical bits that I was talking about earlier, but you want to cache cautiously, right? Only update the changes to your dependencies or to your code. Don't update all the things. Use adequately sized compute nodes within your CI/CD jobs. You want to ensure that you have enough horsepower to execute the things that you're trying to execute, and then run conditional job execution. So you want to make sure that you have your pipelines running in a logical manner. And then finally, right, set build target duration or build duration targets so that your thresholds are acceptable within your your software development lifecycle and your CI/CD continuous delivery processes. So I want to leave you with some links so that you can check out some information. We actually have a report at Circle CI to kind of tell you how you can benchmark your team against other teams that use Circle CI. And this will help you become a this data can help you become a high performing team in the sense of continuous delivery. I've also included the link for the blog post that I was talking about regarding CI/CD engineer. You can check that out at this URL. And then join our Discord server, right? If you want to kind of chat with us and the DevRel team and developers at Circle CI, we're all on Discord, so you can talk to us directly. And finally, for this talk, I would appreciate any feedback that you have. Definitely always looking for constructive criticism so that I can update talks and make sure that they add value to all of your lives instead of just talking at you. So I want to thank all of you for attending, and I hope you have a great event.